Welcome to today's recording of the Sizing Mastery topic, originally happened at the Evolve Partner Summit by Platform.sh in October 2024. The Sizing Mastery will be about what a sizing exercise is and why it's useful to do it and what we want to achieve by doing it. We will talk a little bit about different topics that have an impact on resource consumption and therefore require you to consider this in your project. And then in the end, we will do a little bit of help, or try to give you a little bit of help on how to size your individual projects and make them successful. So what is a sizing exercise? First and foremost, we're trying to achieve a couple of things, but in the end, it is about risk management. We have a couple of dimensions that we want to ideally find a good balance. So we have obviously price, because we want to be at reasonable budgets, or we have budget constraints from our customer. Or we have reliability demands and requirements that require us to go for a specific infrastructure architecture, for example. And that also comes with prices. And then in the end, there's obviously the performance topic. We want to make sure that the project is not only stable, but also performs in a way that users enjoy interacting with it. So when considering all this, we have to go a little bit deeper into the technical side of things and talk about what impacts the resource consumption. There are a couple of topics, and today we won't be able to cover everything in detail, but I want to give you a couple of hints and things to consider. So there's obviously traffic, because with more requests per second, in the end, your demands on the infrastructure side will increase. There's the architecture design overall of your application, the components you use. There is the overall complexity in what you do with your project, if you work with third-party APIs, for example. Then there's the whole topic of caching. Caching is something that in terms of performance is obviously something that's good, but also in terms of resource consumption, it means that we're not requiring as much on the project side of things. Then there's the third-party performance. This is not just third-party APIs and so on, but also different modules that you might require. And then there's something you can heavily influence on your side, which is obviously the coding practices and writing code that performs well and consumes less resources, leading to less requirements for the infrastructure side. So let's dive a little bit into each of those topics. The first one is traffic. So as I mentioned, traffic KPIs definitely have an impact. So if you have, more traffic coming to the site, or in an e-commerce context, you have additional orders coming in, you have maybe a specific distribution of traffic. So during the week it's low, on the weekend for whatever reason it's harder, or you run regular newsletters that increase the number of visitors coming to your site. It's very good to think about this ahead of the project and make sure you understand the kind of peaks that happen on a regular basis, the traffic patterns that you see, and make sure that you understand what you don't know and plan for additional buffers. What you want to avoid for sure is having a project that works under 90%, 80% of the time, but then 20% it does not. And it needs to upscale, leading to additional surprise cost, for example, that nobody expected, and that's something we want to avoid, right? Another recommendation here is definitely to run load tests against expectations. So if you know traffic patterns, if you know the peak behavior of the traffic, you should also load test against this, so you know not just the traffic behavior, but also how your application behaves under this load. One additional thing to consider when doing this is really have a look and question where the data is coming from. So for example, many will use Google Analytics from the customer side if it's an existing project that you want to migrate to Upsant or Platform.sh, for example. Please consider that it might not be the full picture, because not everybody will agree to the Google Analytics cookies, and therefore the data might not be fully accurate. So that's just an additional argument to include buffers. All right, then comes the architecture of your website itself. Here we have a couple of challenges. So obviously it's about the components you use on the one hand, and then the kind of performance of those on the other. So if you require a queue system like a RabbitMQ component or a specific search database like Elasticsearch, OpenSearch, etc., of course they will require additional resources. But you can be very intentional about those because yes, an Elasticsearch will require additional resources, but it will make search way more performant and it will overall very likely decrease the need for resources, because if you run a full text search against a MariaDB, for example, it will perform much worse in most circumstances. So really also think about what you need and what you need it for and make the best use out of that. An additional thing that I see very often not considered in projects is really the use of background workers and those queue mechanisms. If you have tasks that can happen in the background, it could be a really good idea to run them in the background worker container, because that means that the container that the traffic gets hit to will not require those additional resources, and you have really separation of concerns on that front. An additional topic is the overall complexity of your project's design. So with more integrations of, let's say, for example, third-party systems and how often you consume content from there, it also comes with resource consumption requirements. It also impacts the overall performance, right? So if you have in a PHP context, for example, and in many others, it's the same as well. If you talk to an external API, the process is waiting for that API's response. So that can block a PHP FPM worker, for example, which means it blocks it reduces the amount of concurrent requests any system can handle. Here, it is a good idea to really also think about async versus sync. So really, does everything need to happen on the life cycle of the request, so in real time when the user asks for it, or is there the possibility to have it updated in the background and then get it to the user when it's ready? Another mechanism that is quite useful is really think about cached versus real-time responses. You might be able to, cache external responses. It doesn't always have to be like caching for a full day. It can be a couple of minutes, 30 minutes. It can be just a minute or 10 minutes. In heavy peak traffic scenarios, this can already be helpful because you don't have to request this external data as much, and you free up resources at your project's environment. So really have that in mind. There are a couple other mechanisms under the topic of graceful degradation and useful fallback. So if you have a look into that, it really means that those third parties, those third-party systems, you reduce the reliance on those during the real-time communication with your users, for example, and make sure that you're not opening those requests for an indefinite amount of time, for example, implementing timeouts and other of those mechanisms. And then there's caching. Caching has a huge impact. For us, caching has always been part of the scaling strategy as well, because any request that you can deliver from a cache, and in this example or in this slide, I'm focusing on the content delivery network. It means that if those requests are answered by the CDN, it does not require resources on your project. So this means we want to essentially outsource as much as we can to this edge layer. And for that, we need to increase our CDN hit ratio, right? We need to make sure that the majority of our requests are answered by a CDN. There are several ways to do this. You can improve the way, for example, Fastly, which we usually include for our enterprise projects, handles the caching key. So what kind of information is used to determine if a cached response can be used, for example. If it gets more complex, you can think about ASIs, so edge side includes, to render partial responses on your page from the cache, but the ones that need to be individualized can still be fetched from the origin. So there's really, from very simple ways to very complex solutions, there are ways to increase that CDN cache ratio. If you benefit from the integrated Fastly solution that we provide as part of the enterprise projects we have, here is also a small curl command using the credentials that we will give you to check the current hit ratio and actually quite a lot of additional data from the Fastly API to see how you can improve it and where it is today and after you change, for example. So that is very useful to have a look into from a regular basis. Third-party performance. We talked about third-party systems before, but here I'm really focusing more of external plugins. You always have those cases where you are required to add additional business logic to your system, right? Because the product owners, the business owners are requesting it. And maybe you will find existing solutions on the market where you can just install a plugin, install a module, and that provides you the functionality you're looking for. So you don't have to do it yourself, which is great. But also, it means you have to test and monitor the impact on performance because it is code that is not written by you, so you don't know exactly how it behaves. Maybe it also behaves fine under your baseline traffic, but it actually has a huge impact under load. That is something you need to consider. So the only advice here is really to make sure to monitor and test this on a regular basis. We have tools included like Blackfire, where you can really see the difference on the before and after, even before going to production. And that obviously makes a lot of sense to check. In addition to performance and resource requirement, it also, those plugins have an impact on security. So have that in mind as well to make sure that what you bring to your system is actually something that has some kind of validation and follows good practices, not just for performance, but usually that also comes with security as well. Coding practices. So then comes the last topic where you have obviously a huge impact and your team has a huge impact on how the code is written. Usually writing efficient code is very often not the same as writing the most cost-effective code, right? You have deadlines, you need to be quick, you want to deliver value to your customers quite quickly. And in the first iteration, maybe showcasing something that is written quickly makes a lot of sense. But then in your development process, you need to have ways to make sure that code is not just functioning, but it is also efficient and you understand the impact on performance and also resource consumption as a consequence of that. We definitely talk to us about Blackfire builds if you haven't had a look already, because those are a way where you can really automate this kind of impact monitoring again before it even comes to production. Also, the profiling mechanisms we have, not just the PHP and Python profiler, but also the continuous profiling we have for other runtimes these days, give you really good insights into what is consuming, what part of your code is consuming, what amount of time and therefore resources, and impacts the performance. So that is really something that I can't stress enough, to have this integrated into your software development lifecycle and make sure you really audit this on a regular basis as well and give your teams the time to fix it. All right, well, this was a little bit more high level, though I tried to give you a lot of helpful tips on what to consider. Let's look a little bit more into practice and how you can use this kind of information and others to find the right resource configuration for your project. So we will start with an initial sizing, right? So we have to start somewhere. If we have an existing project, we want to look for existing data. So maybe there are metrics from the current system. There can be access logs that you might be able to get, for example, and then there are solutions out there where you can parse the access log to give you an idea of how many requests per time frame you have. But also, if it's a new project, there is usually some kind of assumptions, right? The customer usually has some kind of expectation of, let's say, the number of users coming to the site, the number of leads they want to generate, even if it's an e-commerce context, the amount of money they want to make per month. And you can use that to draw conclusions and make assumptions. Yes, they're not always going to be the best kind of data, but a little bit of data is better than no data at all, obviously. So really try to see what kind of data you can find, and if you need our help, obviously we're happy to talk about this together. The next step is really, okay, how much of that traffic you can offload to a caching mechanism. So will 20% of that hit the project? Will everything go to the origin because it's absolutely uncacheable? Like, really question that and make sure you have an idea on how much the system actually needs to be handled versus what can be delivered by the CDN. And then think a little bit about your design or your architecture of your application. So what kind of services do you have? Where do you expect the most load? Is it more a, let's say, brochure website where everything is cached and it's mostly consuming content on the user side, or it's a lot of user-generated content that will be used? Or are you expecting search to be a heavy part of the site or not? And really think about the different components you need and where this kind of load is expected to happen. Really think about where does this request go? What kind of data does it need to fetch from the different services? And it will give you a better idea on optimization potential for the resource configuration. So there's a couple of things on how you can translate those assumptions and estimates into actual usage of, let's say, for example, in this case, CPU and memory. This is a super simple napkin math example for just the application side of things, but it gives you an idea on how you can easily get there. So let's say, based on the assumptions, we have 6 requests per second at the maximum that we know our system needs to handle. And then we have an 800 milliseconds time to first byte. So this is how much time your application needs to really start returning the response to your users, to your clients. So what you can do, and this is an easy example based on some, let's say, standardized PHP, but it works similar for others. We'll talk about this in a second. You could say that for 6 requests per second at 800 milliseconds time to first byte, you will need roughly 5 CPUs to handle this concurrent traffic. You can do a similar exercise for the memory, where you basically say, okay, now we have 6 requests per second. We know that at the maximum, each request will consume 24 megabytes of memory. And that is something you could actually get from pre-existing access logs and draw some conclusions and see what is the max, what is the average, and so on. And then you probably want to add some buffer for the system itself, or maybe some background tasks you have to run in the same container. And that gets you to an amount of memory that you need at the bare minimum to handle this amount of traffic again. This is something on some of the formulas that we use internally as well to provide you with our recommendations, but this is how you get an idea on what you will be needed at the minimum. And then you have to discuss buffers and things you want to add on top, and what is the baseline versus peak scenarios, and those kind of topics we discussed before. As I said, this was some kind of napkin math based on a standard PHP project, where PHP, for example, has some specific characteristics. In this case, it usually doesn't require a huge amount of memory to start, but with more requests in parallel, you increase the need for memory, because each request, and that's the formula we have seen, each request will require a specific amount of memory from the system. In Node.js, it might be a little bit different because it's running a lot of things asynchronously and in event loops. So that means it could actually require a lot more memory depending on the data that it processes. But that is for, let's say, more of a server-side heavy Node.js project. So an Express.js or like an API, for example, where this is mostly true. But then if you consider using Node.js in a context where it only renders the front-end assets, like static Next.js front-end build, that actually doesn't require a lot of resources to run, but it requires a lot of resources to build. So that is also very different characteristics to consider. Java and Go are also a little bit different, so they will require more memory to even start, but then you won't see a lot of additional memory consumption going up with the number of requests going up. So depending on your stack and the combination of the different technologies you use, this can also have a huge impact on the kind of architecture and the kind of resources you actually need. When we have found our starting place and used that to go live with the project, ideally running a load test and making sure that it worked, we have several ways to monitor how it's going. So obviously you have infrastructure metrics where you can see the consumption of the individual components and how it's related to the overall project resource needs. There is, at least in Upsun today already, the HTTP metrics, where you can see the number of HTTP requests coming into your project and the bandwidth it consumes. This is not the CDN bandwidth, it's really at the origin. And you can also see the top 10 URLs and their impact. So if you see that there is a URL that is requested a lot, that actually responds quite slowly, that is definitely a good idea to look into optimizing the resource consumption and performance overall on this specific type of domain, URL, sorry. To help with that, we have obviously the whole Blackfire tooling that helps a lot. You have the application performance monitoring that will help you identify when and where in your application there are specific peaks. So you can look deeper into this. For this, you can have the deterministic profiler that really gives you an idea on this specific part of the code consumed that many resources and took that long to respond, to send a response, to generate a response. So that is really helpful to understand why something is slow. We also have included in Upsun already our continuous profiler that instead of giving you specific information about individual requests, give you more information about specific times on the system and the kind of functions that consume a lot of time. We even just very recently launched a new feature where you can compare continuous profile information between timeframes. So you can have this before and after comparison, after a deployment, for example. It doesn't have to be on production. It can happen really on a preview environment. So again, it is about understanding where performance impact is coming from, but it's also understanding as a consequence into resource consumption topics as well. And then this is really about iterating. I can't stress that enough, that this is not a static endeavor, unfortunately. So yes, if your traffic and your patterns are really stable and you will rarely see any peaks, for example, it might be fine, but then you are still improving and changing the code underneath, and that can impact the whole resource consumption as well, as we talked about introducing additional plugins, adding a third-party API to the mix, etc., etc. So really, when discussing business requirements with your stakeholders, make sure you're also in the planning, you leave time for testing the performance and testing and monitoring the impact of those changes. That's mostly it from my side. We would also love to understand what you're struggling with. So come to our Discord. You can find me or my colleagues there. And really, if you have struggles with certain areas where it's really hard for you to find a good solution, drop us a note and we would be happy to look into this and make sure we have a way to improve our documentation and provide you with more material and help you really find the best way, the best starting point for your project as well. In the end, we're happy to help. Just reiterating this, we want to make sure you are successful there. So again, we have the Discord channel now. Join us there and we'll be happy to help you. Thank you so much and talk to you soon.